Alright, so we're going to practice writing out ratios. And a ratio is a comparison between two quantities, two numbers. So, um, 2 to 3 is a ratio, and you can write it like that with in odds notation, I believe is what that's called. A lot of times it'll be like that, like a fraction, 2 over 3. So we're comparing two numbers, 2 and 3. Um, and you can have a ratio that's in decimal notation. Um, so 2/3, 0.6 repeating. So yes, it's fairly straightforward to do it when you know the two numbers that you're comparing. But really, ratios can be really powerful for figuring out and dealing with unknown quantities. So you need to be comfortable with writing ratios um, when there's variables involved. So that's what we're going to practice. So kind of translating from a word problem, and which is what you really in the real world when you get into the the upper level math and science, when you're dealing with real world problems. One, you're going to need to be able to translate a situation into a ratio, and two, you need to be able to deal with variables when you're doing that. So that's the fun stuff. So in the first couple of problems, um, these will just be normal ratios that you've dealt with just numbers, and then we'll throw in some variables too. So, all right. So in a water molecule, first one here. In a water molecule, there are two hydrogen atoms and one oxygen atom. So if we wanted to represent that as a ratio of, let's say, hydrogen atoms to oxygen atoms, we would write that as 2 to 1. So that's a comparison of how many hydrogen atoms and how many oxygen atoms in one water molecule. And you could take that ratio and say, I've got, I've got a something, a tiny, 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 tiny cube of ice in which I've got 100 oxygen atoms. If it's all water, how many hydrogen atoms can I expect there to be? Um, you would expect there to be 200 hydrogen atoms. If all the oxygen atoms are bound up with hydrogen atoms to form water molecules. Anyway, getting off on a tangent. Point being, once you have a ratio, you can use it to figure out stuff. Okay, so if we just want to represent how many hydrogen atoms per oxygen atoms there are in a water molecule, we can say 2 to 1. It's a ratio, okay? Let's look at the second one. There are 5 girls for every boy in my astrophysics class. So if I want a ratio of girls to boys in my astrophysics class, um, I would say 5 to 1. 5 girls for every boy, for every one boy in my astrophysics class. So that's the ratio of girls to boys. If I want to do boys to girls, it'd be like that. And does that mean there's 5 girls in my class and one boy? No, but the ratio of girls to boys is 5 to 1. So maybe there's six dudes. Then there would be, I would predict that there's 30 gals, right? Okay, so now we're going to kick it up a notch and throw in some variables, some unknowns. So 50 geese are on that lawn, and I have no idea how many ducks. What is the ratio of geese to ducks? All right, well, I want the ratio of geese to ducks. So um, here's geese, okay? But look, this is not helpful. I have no idea how many ducks. So, what am I going to put down there to represent ducks? Well, just a variable. 50 over, let's say, D. That makes sense for ducks. D for ducks. We don't know how many ducks. But the ratio of geese to ducks is 50 to D. 50 over D. Right? So you'll use this kind of thing to set up equations, inequalities, etc. You'll have a situation in which you know a ratio, but you don't know some of the values. So you can set up the ratio, and then you can use that to solve. So don't be afraid to, if there's no concrete number there, if there's no concrete number, it's an unknown. That's what algebra's for. It's all about unknowns. So you just instead of just giving up and saying I can't solve this problem, what you do is you just write a letter in for that number that you don't know. So 50 geese and who knows how many ducks? All right, 50 over d. We don't know. We can solve this later. I mean, with this information we can't, but we could use this ratio, and if we were given some more information, we could use that ratio to solve. Anyway, all right, there are a certain number of hurricanes per year and a certain number of earthquakes, and I don't say what those certain numbers are. What is the ratio of earthquakes to hurricanes? All right, now I don't know any numbers. So again, don't panic. Um, if you don't know a number, that's what algebra is for. You represent it with a letter. So there's a certain number of hurricanes per year. Um, okay. Oh, but the question is, what is the ratio of earthquakes to hurricanes? So I want earthquakes first. That says earthquakes. Just trust me. To hurricanes. So I want earthquakes on top. So just the most logical thing to me would just call that E. Um, E over H. There you go. That's the ratio of earthquakes to hurricanes. Right? So a ratio is just a comparison between two numbers, and you don't have to know what those actual numbers are. You could represent unknown numbers with variables. Yep. So there you go.